My channel Mathematics with Armin. This is another video on probability, and in this video we're going to look at the addition rule. If you have not subscribed yet, please subscribe to my channel Maths with Armin. Subscribe, and if you have any comments, don't forget to submit your comments, and don't forget subscribe. In this video, I'm going to show you how the addition rule formula is derived. We're going to go through the concept, and then we're going to apply the addition rule to a number of situations there. As with all the videos, at the end there'll be an exercise worksheet. Hope you will enjoy it. So let's start. Now let us look at the addition rule. Here we're going to look at the union of events, and we're going to use the term or. Okay, so let's consider the probability of either of two events occurring. So one event or the other event occurring. And this year we're going to use the union of, so the or refers to the union of events. So when we have or, that's the union of events. So the probability of A or B, which we can also write as the probability of A union B. Okay, so we're going to look at that. Now let's look at the union of two events. I'm going to use an example to illustrate the union probability of the union of two events, and then to be able to derive a formula to determine the probability of the union of two events. So in this example here, we have a class of 30 learners who have a choice of two subjects, mathematics and accounting. Right. So there we have the sample space, and we use a rectangle there. And then the event M is the event of taking mathematics. That's represented by that magenta circle. And the event A, taking accounting, that's represented with the aqua blue. Okay. Now there are 30 learners taking in the class. So that's where the 30 goes. That's the total number of learners in the class. Then the number of learners who take mathematics is 20. So though that goes to the mathematics learners, and 15 take accounting. So let's place the 15 there. But what do we notice about the mathematics and accounting? If I find the sum, we see that it gives us a sum of 35, and which is a lot more than the class size of 30. So how do we explain this? That's correct. There are some learners who take mathematics as well as accounting. So in other words, there's an overlap. In other words, we have the two circles there need to overlap. So in other words, that's the situation that we have. And what is the overlap? The overlap is 5. 35 minus 30 gives me 5. So we can see there's 5 learners taking mathematics, and the same 5 learners also take accounting. You see there? There's the two colors, 5 taking mathematics in the background there, and 5. So we've got the same, so we have to remove one of those 5s. Right? Now we can calculate the remaining portion there. So that is, I've got 5, which is those who take mathematics as well as accounting. And then if I take the 20 from mathematics minus 5, that gives me the 15. And for accounting, 15 minus 5 will give me the 10. And now we can see 15 plus 5 plus 10, that gives me my 30. So that I've represented that properly in this Venn diagram. Let's look at the probability now. So we want the probability of taking mathematics or taking accounting. So the number taking probability for taking mathematics, we add that to the probability taking accounting. So that's 20 over 30, and there are 15 learners taking accounting, so it's 15 over 30. But we've got an overlap, right? So we need to remove that portion. So we remove what that's 5, so it's 5 over 30. And if we just balance this out, 20 plus 5 minus 5 gives me 30, and 30 over 30, that's correct. 30 over 30 is exactly 1. Okay. Now we can see, if we take the probability of the union of two events, then it's the probability of the one event plus the probability of the second event minus the probability of their intersection, right? So we state it this way: the probability of A or B is the probability of A plus the probability of B minus the probability of their intersection. Now let's just recap the addition rule. Union of two events, probability of A or B is A, probability of A plus the probability of B minus the probability of A and B, which we can also write instead of or, we can write the union symbol, and instead of the and, we can write the intersection there. So it's the probability of the one event plus the probability of the other event minus the probability of their intersection. We are now going to look at some examples where the addition rule is going to be applied. Let's take the first example here. Given two events A and B, such that the probability of A is equal to 0,5, the probability of B is 0,3, the probability of A and B is 0,2, and we have to calculate the probability of A or B, which is the same as the probability of A union B. So let's use the addition rule. Probability of A or B is the probability of A plus the probability of B, subtract from it the probability of A and B. Let's look at our given information. So we do a direct substitution. Probability of A, as you can see, is 0,5. So let's substitute it in there. Probability of B, let's see, that's 0,3. So let's substitute it in there. And the probability of A and B is 0,2. So let's substitute it in there. We do the calculation. 0,5 plus 0,3, subtract from it 0,2, and that gives me, that's correct, 0,6. So the probability of A or B is equal to 0,6. Now we're going to look at another example after this. Let us consider another example. Here we're going to take a fair six-sided die that is being tossed. Event A would be an even number is obtained. Event B, a number less than 5 is obtained. We want to calculate the probability of A or B. So let's look at the sample space first. What would our sample space be? Tossing a fair six-sided die. It would be 1, 2, 3, 4, 5, or 6. And event A would be an even number. Which are the even numbers that I could obtain? That's correct, a 2, a 4, or a 6. So the probability of a occurring is going to be 3 over 6, which is how. Let's look at event B. A number less than 5 is obtained. Which are the numbers less than 5? 1, 2, 3, 4, 4. So the probability of B would be 4 over 6 or 2 over 3. We want to calculate the probability of A or B. So we will use the addition rule. There we have the addition rule. Probability of A or B is the probability of A plus the probability of B. Subtract from it the probability of A and B. Now let's substitute into the formula. Probability of A, what would that be? That's correct. We have it as 3 over 6. Probability of B, we have it, and that is 4 over 6. Subtract the probability of A and B. Let's look at event A and B. Event A and B means that it must be an even number, and at the same time it must be less than 5. So which are the cases here? So it must be even number. There's the even numbers, and which ones here would be less than 5? That's correct. It will be a 2 and a 4. So the probability of A and B would be 2 over 6, which is 1 over 3. So let's substitute it in our formula, 2 over 6, and now we just need to simplify. 3 over 6 plus 4 over 6, subtract 2 over 6. What would that be? 3 plus 4 subtract 2. That's correct. It's going to be 5 over 6. So the probability of A or B is going to be 5 over 6. Let's look at another example. Here we're going to look at the tossing of two fair six-sided dice. Event A would be both numbers are even. Event B, at least one of the numbers is a 2. So we have event A, both numbers must be even. Event B, at least one of the numbers is a 2. And we want to calculate the probability of A or B. Let's start off first of all by looking at the sample space. If we toss 2 die, what would the sample space be? That's correct. These are the cases there. 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, etc. If we count that, that's 6 by 6. So the sample space, the size of the sample space would be 36. Next, both numbers are even. So I want to look there. Let's look at the sample space and now we check where do we have both numbers even. That's correct. That can be a double 2, and we can have a 2 and a 4, and we can have a 2 and a 6, and we can have a 4 and a 2, and a 4 and a 4, or a 4 and a 6, or a 6 and a 2, and a 6 and a 4, or a double 6. If we count that, that gives us, that's correct, we get 9. So the probability of event A occurring would be 9 over 36. Let's look at event B. We want at least one of the numbers must be a 2. Let's look at the sample space again. Where do we have a 2? There we have, in this column we have a 2, and in that row will be a 2. And if we count the total there, that's correct, we get 11. Now we want to determine the probability of A or B. So we use our addition rule. There we have our addition rule. Probability of A or B is the probability of A plus the probability of B minus the probability of A and B. So let's substitute now. Probability of A would be, that's correct, it would be 9 over 36. So let's substitute. There's 9 over 36. Probability of B, that would be, that's correct, 11 over 36. But we want to determine the probability of A and B. So A and B means both numbers must be even, but at least one of the numbers must be a 2. Let's look at that now. Let's see there. So these are the cases. You can see both numbers are even, and I've got a 2. Both numbers are even, and there's a 2 in. Both numbers are even, and there's a 2 in. Both numbers are even, and there's a 2 in. Both numbers are even, and there's a 2. And if we count that, 1, 2, 3, 4, in other words, we have 5. The size there would be 5. So the probability of A and B is going to be 5 over 36. And 5 over 36 subtracted from 9 over 36 plus 11. 9 plus 11 is 20. 20 subtract 5 gives me, that's correct, 15 over 36, which can be simplified as 5 over 12. So the probability of A or B is, this example, 5 over 12. Now, two events are mutually exclusive if and only if. See, there's two events. So the first one is they cannot occur at the same time. So that's one of the main requirements of being mutually exclusive. Or they don't have any elements in common, right? You can see they have nothing in common there. They don't overlap. So the intersection of the two, you can see there's the intersection. The intersection is empty. There's no intersection. And the probability of A and B, right? A and B is 0. Then we can also now have that the number of elements A or B is the number of outcomes of the one event plus the number of outcomes of the other event. And the probability of A or B, if we take our addition rule, see there's our addition rule, because they are mutually exclusive, then this addition rule there, you don't have to subtract, that is 0. So in other words, the addition rule is now just probability of A or B is the probability of A plus the probability of B. There's no need to subtract because they have nothing in common there. Now let's look at the union of mutually exclusive events. In other words, we look at the addition rule here. So that is the addition rule. Probability of A or B is equal to probability of A plus probability of B minus the probability of their intersection. But because they're mutually exclusive, the probability of A and B is 0. So that is a 0. So in other words, the addition rule is now modified, and the addition rule is probability of A or B is the probability of A plus the probability of B. Let's just consider an example of the union of mutually exclusive events. So given two mutually exclusive events A and B, where it is given that the probability of A is 0,5 and the probability of B is 0,3, and we have to calculate the probability of A or B. So let's start off first. We want the probability of A or B, so let's use the addition rule. Probability of A or B is the probability of A plus the probability of B, subtracted from it probability of A and B. Let's see what is given. Probability of A, you can see there is 0,5. So let's substitute the 0,5 in the formula. Probability of B, you can see is 0,3. So let's substitute that. There I get 0,3. And probability of A and B. Now, if events are mutually exclusive, we know the probability of A and B should be 0. In other words, we now substitute a 0 in there. And this gives me probability of A or B is 0,5 plus 0,3, which is 0,8. Now let's look at another example where we're going to apply the concepts of mutually exclusive events. Here we have two events A and B, and it's given that the probability of A is 0,6, probability of the second event is 0,3, and probability of A or B is 0,8. Are the events mutually exclusive? Okay, so we have to show, if we want to show them mutually exclusive, we have to show that probability of A and B would be 0. So let's use our addition rule. There's our addition rule there. Probability of A or B is probability of A plus the probability of B minus the probability of A and B, or the probability of their intersection. We are given the probability of, let's put that there. So we are given the probability of A or B. See, that is 0,8. Say there's a 0,8, and we can insert it there. Probability of A is given, that's 0,6, and we can substitute there. Probability of B is 0,3, and we can substitute it there. And so the only one that's missing is probability of A and B. Doing a little bit of manipulation, we transpose the probability of A and B on the left side, and then we have 0,6 plus 0,3 minus 0,8. I do the little bit of arithmetic there. That gives me 0,1, and we know 0,1 is definitely not 0. So therefore we can deduce, you see, 0,1 is not a 0. So the probability of A and B is not a 0. And because of that, we did not get the 0. We can then deduce that A and B are not mutually exclusive events. Now let's look at the union of independent events. Taking the addition rule, there's the addition rule. Probability of A or B is probability of A plus the probability of B minus the probability of the intersection of A and B. But because they're independent, the probability of A and B is actually the product of the probability of A and the probability of B, so that can be replaced. Probability of A times B. So in other words, for the union of independent events, the probability of the union is the probability of A plus the probability of B, but now we can subtract the product of the two probabilities, right? So that's the formula we're going to have if we have the union of two independent events. Now let's look at an example of the union of independent events. So we are given two events, A and B, which are independent, such that the probability of A is 0,5, probability of B is 0,3, and we have to calculate the probability of A or B. Now let's start off with the addition rule. Probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. Let's substitute now. But before we do that, let's note, if A and B are independent events, then we know the probability of A and B is equal to the probability of A times the probability of B. So we'll replace this probability of A and B in my formula with the probability. So we replace that A and B, and we replace it by probability of A times the probability of B. Now let's do the substitution now. Probability of A is given. That's right, it's 0,5, and that gives me 0,5 in there. Probability of B is given, that's 0,3, and now we just have to substitute. We have to do the product there. Probability of A is 0,5 times the 0,3. We do the little bit of arithmetic, I get 0,565. So the probability of A or B is 0,65. Now let's consider this example here. We have two different events A and B such that the probability of A is 0,5, probability of B is 0,4, and probability of A or B is 0,6. Right? Now we are asked to determine whether A and B are independent events, and we have to justify our answer. So if they're going to be independent, we have to show that the probability of the intersection is going to be the product of their probabilities of the two events. So let's see there, we take our addition rule, and we are given some values, so we can do the substitution. Probability of A or B, that's given as 0,6. Probability of A is 0,5. Probability of B is 0,4. And now we can calculate the probability of A and B. If we calculate that, it's 0,5 plus 0,4 subtracting 0,6, and that gives us 0,3. Okay. We also have to calculate we calculated this portion. Now we need to calculate the product of their probabilities. Probability of A, that is given as 0,5 times 0,4, and then if I do that product, that gives me 0,2. And we now notice that 0,2 is not the same as 0,3. In other words, we see the probability of the intersection is not equal to the product of their two probabilities, right? That's what we have there. So in other words, it's not independent. Therefore, we'll say A and B are dependent events. Now let's look at the exercise worksheet. In these two questions, you'll have to use the addition rule. In the first question, you have to calculate the probability of A and B. And in the next question, question number 2, you'll have to determine the probability of A or B. The solutions of these two questions you'll find at the end of the video. And in both these, you'll have to use the addition rule. Now, in question number 3, you'll have to determine the probability of A or B, but here it's given that A and B are mutually exclusive. Question 4, you have to determine the probability of A or B, but in this case, the A and the B are independent events. The solutions of these two questions you'll find at the end of the. I do hope that you've enjoyed this video and you now have a better understanding of the addition rule applicable to probability. Also, I have prepared many other videos on grade 10 to 12 CAPS mathematics topics. Just go to my channel Maths with Armin, and if you have not subscribed yet, please subscribe and like, and also share this video with your friends and classmates. Don't forget, please subscribe. Now let's look at the solutions to the exercise worksheet. Solutions to question number 1. And the solution to question number 2. You may pause to follow the solutions. Here are the solutions to question number 3. And the solution to question number 4. I trust that you've enjoyed this video, and please subscribe if you have not done so. Thank you. I do hope that you've enjoyed this video and you now have a better understanding of the addition rule applicable to probability. Also, I have prepared many other videos on grade 10 to 12 CAPS mathematics topics. Just go to my channel Maths with Armin, and if you have not subscribed yet, please subscribe and like, and also share this video with your friends and classmates. Don't forget, please subscribe.